Well, this problem is related to electric flux and Gauss theorem. There are three charges and we want to compute the net flux passing through this area. At this point, I would like to remind you the Gauss law. It says the net flux passing through any hypothetical closed surface is equal to the net charge enclosed by that surface divided by the permittivity of the medium. So the net flux equals net charge enclosed by the closed surface divided by the permittivity of the medium. So psi equals sigma q over epsilon. And also the electric flux is equals to electric field intensity times the surface area of the Gauss surface or the closed surface that we are considering. So remember, it has to be a closed surface. It must necessarily be a closed surface in order to apply the Gauss theorem. So this equation we derived, this is actually the Gauss law. Okay, now we want to compute the flux passing through this area. I take this area to be capital A, right? And there are three charges, each plus q. Now I can compute the flux passing through this area separately due to individual each charges. So first I can calculate the flux passing through this area due to this charge, and then again I can find the flux passing through this area due to this charge, and then finally due to this charge. And then when I got those values, I can simply add, because flux is a scalar quantity, right? It is not a vector. So if I know the value due to this and due to this and due to this, I can simply add and get the net flux passing through this area. Now first I'm going to consider this charge. So here in this problem I'm going to consider the charges separately. So first I'm going to consider this charge, therefore I'm neglect these two. So in my system I have only this charge, which is plus q. And now I'm going to consider the Gauss law to this charge. Now here we have a cube, right? And I consider this area to be capital A. Therefore, the total area of this cube is we know there are 6 faces in a cube, therefore 6a. Now if I consider this charge, the flux coming out of this charge is completely captured by the total surface area of this cube. In fact, this cube is a closed surface, so I can apply Gauss theorem, right? So I can write using Gauss law. Right, I'm considering this charge and applying Gauss law. So I can write the flux psi dash. I take psi dash to be the flux coming out of this charge. That means the total flux captured by the total surface area of this cube is equals to, now some electric field intensity value. I don't know what the value is, so I take E1 times the surface area of the Gauss surface or the closed surface, so which is here 6a, is equals to net charge enclosed by that surface divided by the permittivity. So I consider only this charge, I ignore these two charges. So in my system only this charge is there, so it is q over epsilon naught. Epsilon naught is because either this is in vacuum or in air. Okay, so now I have the total flux coming out of this charge, right? But I want only the fraction of the flux going through this surface. Now here the total surface area is 6a, but we want only to compute the flux passing through this A area. Therefore, what I want to do is uh, I want to divide psi dash by 6 in order to get the flux passing through this area. So let us take that to be psi 1. So I get here from this E1 over A equals Q over 6 epsilon naught. Therefore, I can write psi 1 is equals Q over 6 epsilon naught. Okay, so we just calculate the flux passing through this surface due to this charge. And now I'm going to consider this charge, okay, which is at the corner. Now if I consider this cube, I just minimize it, I mean shrink the size of the cube, just the purpose of to explain. So here the charge, now I consider only this charge, okay, which is plus q. Now I want to compute the flux passing through this surface, which is ABCD surface. This is so in the previous one, due to this charge, it is easy for us because it's inside a closed surface. But in this case, the flux from this charge spread every direction, right? So only some fraction of the charge comes through this surface and some of them comes through this surface as well. So in this problem now, what we want to consider now, in order to apply Gauss theorem, we have to consider a closed surface that encloses the charge. But if I consider this cube, it won't happen. So in order to do that, I'm going to do a trick. I take another similar cube, very identical to this, and I'm going to place it here. So one cube I place here, and I take another cube in this side, and another one, and I'm going to place another 4 on top of each, so that I will get this large cube, right? So now the charge, this plus q charge, would be exact center of this large cube, right? Let me mark that. So it is at the center, which means if you draw two diagonals, like one from this corner to this corner and another one from this corner to the other side corner, so it will intersect at a point, so which is the center, right? So at that center we have this plus q charge, right? Now I'm going to now I can see here, this is the plus q charge. It is enclosed by a large surface, and but what we want to compute is the flux going through this area, which is ABCD. Okay, so here now again I'm going to use Gauss theorem, applying Gauss law. Now we know this area is A, therefore the surface area of this one is 24A, because each side we have 4A into 6 faces, so 4A into 6, 24A. So now I have this large cube as the closed surface, and then I can apply the Gauss law. So which is, I take the psi double dash as the net flux passing through the total surface area of this large cube is equals to some E2. I don't know the value of electric field intensity. I take E2 and is equals times the surface area here is 24A is equals to net flux enclosed by that surface is Q divided by permittivity of the medium E0. Okay, now I know the total flux going through the surface area of this large cube, but I want only the flux going through this area. Therefore I want to divide psi double dash by 24, right? Because there are 24 equal parts. In order to get flux going through only this surface, I want to divide by 24. I will take this as psi 2. So it's going to equal to E2 into 24 is divided. So we get E2 into A equals Q over 24 epsilon naught. Okay, so I get psi 2 is equals to q over 24 epsilon naught. Well, so we found the flux passing through this area due to this charge and due to this charge, and then finally we have this one, right? Now if I consider only this one, only this charge, now this charge is symmetric under rotation. Now for example, if I take this cube and rotate, right, rotate by 90 degrees, yeah, rotate by 90 degrees, so this point of this charge comes here, this charge comes here, right? If I rotate it, right, and then it is exact the same, right? So we have a b c d surface. Now if I rotate it, a points go here, b comes here, c points comes here, d comes here. It's just a rotation. So we get this charge here, and the calculation would be exact similar to this. Therefore the flux going through this surface due to this charge is going to be the same as this, right? So I can take, let it be psi 3. So psi 3 is equal to psi 2, which is q over 24 epsilon naught, right? Okay, now what I want is the total flux, the net flux passing through this area. So let me take the total is psi t. So psi t equals psi 1, the flux through this surface due to this charge, plus due to this charge, which is psi 2, plus psi 3. Now I can write this psi t equals psi 1 is q over 6 epsilon naught, plus, now these two are same, therefore psi 2 plus again psi 2, 2 times psi 2, right? Anyway, I write down as psi 2 is, then we get q over 24 epsilon naught plus q over 24 epsilon naught. So if we simplify this by taking the common denominator, 24 6 comes, we get q over 4 epsilon naught, which is the answer that we are required to calculate. Okay, so I hope this explanation is clear, and if anything wasn't if anything isn't clear during my explanation, you may let me know. Okay, take care, study well, bye bye.